SandMap is an educational tool which provides the means of introducing the real dimension of space into the educational basis, visualizing difficult concepts from the field of physics, mathematics, geography, or even history upon three-dimensional sand formations. Users may reform the sand, while the system responds to show the geographic information adapted to the new morphology of the sand in real time. The user immediately grasps geographic concepts and gradually establish more complex relations, promoting spatial comprehension and skills improvement. Regarding the hardware components, a depth camera acquires the depth of the SandMap surface, while a projector is utilized to project geospatial data on the sand based on the 3D information of the depth camera. All of these components are coordinated by a computer program, serving as the sandbox's central control system. Gaugamela. Simulating the Battle of Gaugamela, one of Alexander the Great's most iconic military victories, using a sand map or interactive sandbox can provide a unique and educational experience. The Battle of Gaugamela, fought in 331 BC, was a pivotal moment in history where Alexander the Great faced off against the Persian king, Darius III. Here's how such a simulation might work. The sand could be shaped to show the rough topography, including the river, hills, and open field where the battle occurred. Army deployment. Using miniatures or markers, you can represent the Macedonian and Persian armies, positioning them as they were at the start of the battle. This can help illustrate the differences in troop formations and numbers. Narrative and learning. Throughout the simulation, a narration or text overlays can provide historical context, explaining the significance of certain decisions and how they affected the outcome. This would help students and enthusiasts explore various strategies and tactics employed by Alexander and Darius during the battle. In the extended version of SandMap, AI4Copernicus ecosystem was utilized, creating 3 exercises using the following AI4Copernicus services respectively: Sentinel-2, change detection, deep network for pixel-level classification of S2 patches, long short-term memory, neural network for NDVI prediction. The first exercise is called Estimation of the Affected Areas Extent by Wildfires. The exercise aims to highlight the extent of the vegetated areas which were affected by the wildfire of 2021 in the region of North Evia in Greece, the wildfire of 2023 in the region of the Rhodes Island. Initially, the students are informed about the wildfires that have been happened in several areas of Greece, while natural and infrared colored composites from the affected areas, captured before and after the fire events, are displayed on the sand. At first, on the images captured before the fire event, the students are asked to identify the vegetated areas, displayed with green and natural composite and with red and infrared composite, and estimate the affected vegetated areas, while afterwards, the colored composites captured after the fire event depict the burned areas. Finally, 2 images, created by the Sentinel-2 change detection service of AI4Copernicus, which includes the changes that the fire provoked, are displayed, highlighting the ecological catastrophe of a wildfire. The second exercise is called Automatic Classification and Localization of Tree Crops using Artificial Intelligence. The main goal of this exercise is to inform and educate students and citizens about the use of AI in precision agriculture, and in general, in EO. Initially, the significance of open and large data sets is highlighted, while, afterwards, a short presentation about applications of AI in EO imagery is conducted, aiming to retrieve valuable knowledge for the desired areas. Finally, some of the state-of-the-art tools and services, including AI4Copernicus ecosystem, are analyzed in order to highlight that all citizens are able to perform advanced AI techniques without IT expertise. For the design of the exercise, the deep network for pixel-level classification of S2 patches service is utilized, producing a deep learning model which is able to predict the areas that have high probability to include tree crops using Sentinel-2 natural-colored composites. Thus, during the exercise demonstration, the teacher is able to use SandMap in order to display the Sentinel-2 natural-colored composites, highlighting the difficulty for humans to identify the tree crops on the image due to medium image resolution, while afterwards, the predicted images extracted by the trained model are displayed, proving the effectiveness of the AI model. The third exercise is called Prediction of Vegetation Health using Artificial Intelligence. The main goal of this exercise is to inform and educate students and citizens about the advanced topics of AI and EO, including forecasting using a spatio-temporal dataset. The instructor initially presents the NDVI index and its relation with the vegetation health, while then, a short description about the techniques that are able to predict NDVI values in an area using a spatio-temporal dataset introduces the students to the topic of forecasting in the precision agriculture. Afterwards, the instructor displays an NDVI image on SandMap in different timestamps, aiming the students to comprehend the changes of vegetation health through the years. Finally, she or he utilizes the trained model predicting an NDVI image with a time horizon of 1 month, while the reference NDVI image is also displayed in order to evaluate the differences between the predicted image and the reference image. Regarding the dissemination of SandMap, it has been demonstrated in many elementary and high schools from all over Greece, but also in multiple university European students, scientists, and conferences, while the current version of SandMap has been integrated and is utilized by a private school and a maritime museum. It is estimated that thousands of students and citizens have been interacted with the SandMap platform. As a conclusion, we think that SandMap can bring the education to the next level, rising spatial intelligence to our future citizens.